Hello guys, I think we're live now. Just doing some audio checks and making sure everything is audible, right? I think this is the playlist I want to play. Okay, good to know that the odds are working this time. And yeah, hello, welcome all in. Just trying to find the playlist. Come on. Looking for Robin's playlist every time. There you go. I found it. We found it, and then we can play the song. Hello Robin, how's it going? Just talking about you, dude. As usual, running on your playlist. Partly because I just can't be bothered fixing some time to actually create a really good playlist, and this one already exists, so how are you all doing? It's good to see most of you, or some of you. I think there's only 2 of you watching now, but yeah. So Robin, are you still partly drunk from the celebrations? That's what I want to hear. But yeah, well done, man. Well done on finishing university. And if there's anyone watching, you should all congratulate Robin for finishing his university course. So he's a real boy now. Anyway, let me get the code up. And yeah. Oof. Let's get ready to do some C++, shall we? What's the audio volume like, to be honest? It's here. Yeah, okay, it's good enough. It's good enough. I'm good. Been celebrating my birthday today. Oh, happy birthday. Happy birthday, Robin. My brain still is. You should, yeah, man. Are you celebrating anything special? Like, are you doing anything special for the celebration? Or are you just going to be chilling at home? And then... So let's just edit this out. I hate the heart emoji there because I can see it. And now we're good. Yeah. So what do you guys do in Sweden? Do you have a birthday cake? I'm guessing you do, right? Birthday cakes and some snacks for birthdays. Because here in the UK it's basically the same. I mean, whenever someone throws a party for their birthday, there's always a cake, as well as some little snacks. Yeah. So, right, last time we actually got some code that reads all the lines in the file, right? And this is a very, very large file indeed. The one I have here is only 165 megabytes, but that's only because it has, I think, something like 10 million lines. So in the past stream, we managed to read that file in something like 4 seconds, right? Which was fine. It was only like a proof of concept for reading files with the memory IO. Since then, I've actually rewritten some of this code, and I fixed some of the bugs that were here. So we were getting the incorrect number of lines for the big file, but now we actually get the correct lines, the number of lines read. And I've also added the very simple code to just calculate the temperature information for each city, right? So long story short, this problem is actually a very easy one. So what we have to do is we have to kind of read in this file, which is the weather station. Let's see if we can get an example here. So this is what the file kind of contains, right? Something like this. We no longer have to have a new line at the end. I fixed that bug as well. And it just contains a little like town name and then also a temperature. But the temperature is kind of followed by the semicolon here. So it's supposed to be a CSV file. I guess it's not really a CSV without the comma. It's not really a comma separated list. But this is what we have here, right? So in essence, it's just about finding, for each line, kind of finding the position of the semicolon. And then the bit before that is the name of the town, and the bit after that is the temperature, right? And with those temperatures, you can do things like tallying them up, so adding them as you go to a total, and then calculating the average at the end, as well as kind of updating the minimum and maximum values of that particular town, right? And obviously, as you can probably guess here, Brock, you've already said it, we need a map to store this information, right? So actually, this function here that reads the lines is returning me a map from a string to a temperature data. Temperature data is simply just a structure I added here to hold the information that we needed to calculate the solution for the problem, right? So we need a minimum, we need a maximum, and to calculate the average, I did totals and samples here. And basically, I'm trying to avoid calculating the rolling average by just doing the total and then the samples, the number of samples, and then getting the average at the end of the program, right? So it should save some calculations there. But this kind of works well. I mean, it's still very, very slow for all means, right? So if we do a test on this, so if we go into the build, and then we do Unix, rel, ninja, and then test, we have the thread pool thing. You know, this is reading that entire file that has 10 million lines, and it takes about 4.37 seconds, right? And I am running this on 4 workers. It says ankerl here, but really this means the number of workers that we have for the thread pool, and the chunk size of 64 megabytes, right? So chunk size in my case means how much of the file I want to map into memory at one given time. Okay, the music is a little bit loud. Thank you, Robin. I think I missed a message, so... Right, that should be a little bit better. No? Let's hope so. Actually, Miss Mesh, I met an old friend yesterday and we did some bowling and partying. Yeah, cake is a classic. Nice, nice. I do love bowling as well. The only thing is that I'm actually quite terrible at it, so I never know whether I'm going to hit the pins or if I'm going to, you know, get the ball out. But anyway, yeah, so going back to this, chunk size is how much of the file I want to map into each of the threads, right? So each of the workers, shall we say, is going to be running this function here, so you can see, where are we? So it reads my lines, my chunk data, and it merges whatever is returned from this file, which a chunk data in this case is simply that map that I explained to you guys before, where we have strings to the temperature data. So each worker is going to be running one instance of these lines with the correct chunk, right? Offset and chunk. As well as, you know, whenever that's terminated, whenever that's finished, it's going to merge into, you know, the results here into a bigger map, right? So that's what it's doing, basically. It's not too difficult to understand. It's basically the same thing as what you can probably like think of as a naive solution here. But yeah, I mean, I purposely left the map implementation here because I want to show you how actually slow the C++ standard maps are. So the C++ standard map is. So as you probably know, C++ standard map is a simple kind of... One sec, I'm replying to a message. Anyway, yeah, so the C++ map is basically just a flat map where the indices are sorted, right? So all of the map data is sorted by the key, right? And when looking up, it actually performs in, I think it's O log n, O log n, which is kind of high, really. It's not a constant time, so it can be slow. You know, if you have very, very big maps with a lot of cities in it, which is the case for this example, as you can probably see in a bit, lookup becomes the bottleneck here. So actually, the lookup for map is actually very, very, very high. One thing we could improve on is, instead of doing the map here, we could instead, I think, include the unordered map, right? So if we do that instead, so if we do unordered map, let's see how fast it actually becomes here. And I'll tell you what, it's not going to be that much faster, but you will see the example that I mean. So whenever we had std map, we're going to do, let's actually remove this. Std, oh. Is that a copyright strike? I believe so. Okay, so I think that's all of the maps that we have to replace. Let's try and build this and see what happens. Nope, it was not. So what else do we have here? Another map, another map. We can probably just remove that, I guess. yeah, this was needed as the kind of comparison function here for the std map, just so you know you can store strings in the key, but also compare it to string views. That's how you do it in C++. Okay, now, let's move away from Zelda music because it's gonna give us a copyright strike. So how fast it is actually compared to an ordered map, to the ordered map, right? So in this case here we get like an improvement of essentially like 3 times, right? It's mostly 3 times. Hello Morpheus, welcome to the stream, man. So you see, by doing a simple switch between the C++ normal map, so std map, to an ordered map gives us a big improvement, right? Which is good, kind of what we want. We're heading in the right direction. So this is 10 million lines of this type here being read in and processed, right? So we are actually processing the name of the town, and we are calculating this the minimum, maximum, and average for each of the towns here, and storing them in a map, right? So in this case, it takes about 3 times as quick, right? However, this is not actually the quickest option we have available if you don't want to write anything very specific, because you can, in fact, write a very specific map for your data. So for example, I could use information as like, what is the longest string that I have? What is there any like patterns with the characters that appear in my keys that I could kind of create a very sort of efficient hashing function for? Is there anything that could help me out separate all the possible different cities that appear in my data here? And the answer is yes. In most times you can actually write a very good specialized hashing function, but the only problem is that it doesn't really generalize very well. So every time a new city can be added to the data, every time there's a new weather station in this problem here, that hashing function may not work because you may have a lot of collisions, so it kind of renders the algorithm a little bit worse. However, we can do one thing here, which is to just use a more efficient implementation of a map, right? And for that there is a very good implementation called dense map, which is by this guy called Martin Ankerl, I think. So another dense. And if you are interested in only using a very performant map that's kind of very generic and it works for most of the containers out there, so like I'm talking about strings and string views and stuff, then C++23 flat map, I can try that one. I've not actually tried that one yet. I know that it's in the standard, but Brock, yeah, let's try that one before the dense map and compare it. But I was just going to continue here. So dense map is actually a very performant implementation of an ordered map, dense map. And whenever I have to squeeze performance out of maps, I always look to use this implementation here because it kind of blows all of the other C++ either standard or third-party map implementations out of the water. So it's simply just really quick, right? And if you are interested in what algorithm it uses, and it does say here somewhere, and you can read more about the algorithm itself. So Robin Hood backward shift deletion, and you can see how what hash functions it implements and stuff. But yeah, long story short, this one is very performant per se. Now, one of the things I haven't yet tried, Brock, is using flat map. So let's look for that. Let's look at that one. So flat map, CPP 23. I believe we already have the right standard here. No, we don't. Let's just put right standard and then reconfigure. So we have C++23 with Clang, and I'm not sure if it's supported by Clang. Yeah, maybe we can find that out. I've certainly never used it before, so. Let's look at a trusty compiler support page and look at the flat map. And yeah, no, this is not supported by anyone, dude. So I'm looking at Clang here. Wait. Yeah, it's gonna be a bit difficult to try this out because it doesn't actually have support in any compiler. Unlucky. So yeah, I mean, I was hoping to be able to test this, but yeah, I mean, can we even include it here? Let's see. Maybe the page has not been updated, right? So yeah, flat map is not an available header, which means I'm just gonna have to show you guys how to how to use the ankerl map here. I have done some testing on this already, and I've already I've already included another dense here, as you can see. So on Conan, you know, the dense map is available as another dense. And all you have to do now is basically to include the library itself. I think it's called ankerl, another dense. And we can switch all of these map types to the ankerl one. So it's ankerl, I believe, another dense, map. And this is basically it. That's all we have to do. And it works in kind of very similar way to the standard maps. So, which is another reason why you should probably use this map instead of other implementations, because this is actually fairly compatible with the calls to the standard map itself. So whatever code you have written in C++ that uses the standard maps, they will also work for the ankerl type. And then down here, we also need to have that replaced. Now there is something at the top. I probably want to remove another map. Okay. And we had a kind of like a 3x performance improvement. And now what do we get with ankerl? We got 0.82, which is, you know, in terms of performance, is actually nearly half as twice as performant. And if we keep doing it a few times, you can see that, you know, it's about right. That's what we get, 0.8, 0.7. So it's a huge improvement on the annotated map from the STD standard as well. That's why I always like to use this one. You may have seen this map in one of my videos already, where I was kind of explaining or comparing the Rust web frameworks to the C++ web frameworks. And to make things a little bit faster, I use this map because it's a very simple replacement to the standard maps, and things just work very well. So yeah, I mean, essentially I kind of this is the main thing I wanted to talk about, of, you know, how you can kind of gain performance by doing a simple, very mild, you know, minimum change between standard map to standard unordered map. And still, if map lookups is your bottleneck, you can take it further and look for a more kind of modern and performant implementation of a map, which is this at the moment. I think this one is probably one of the best ones here and out there, and it's kind of free to use in any project. I think it's MIT license, isn't it? Yeah, MIT license, so it's very permissive, very permissive actually. So there's no reason not to use that. Of course, taking this a step further, we would come into the kind of like creating your own very specific maps, which is what I said you can do. So for example, if you know certain information about your keys, you can make it so the hash function is very specific, yet very fast to your particular keys, right? But in our case, I don't want to do that, because the keys can be kind of anything, and I don't really know the number of you know, first of all, the number of cities, and, you know, what the different cities are that we can get in this file. So in this case, I'm going to leave it as a very generic implementation here by just using the unordered dense map, right? Now, one of the things I want to kind of take a look into this stream as well, because obviously, yes, we still have a long time to go. We've just started the stream and this is kind of already done, right? I want to dabble with some of the branchless coding, right? So branchless programming. So branchless programming is the idea of kind of removing some of the branches that we have here. So for example, you know, the main branch that we actually have here is this one where we kind of check each character to make sure that it's not that it is a new line, right? So whenever you have a branch and the assembly code generated has a branch in it as well, so it has a jump or has a branch not equals or whatever, then the CPU can make predictions about your code, which means it might miss the predictions. Well, it can make predictions, but it will miss the predictions. which means your code will run, you know, a lot slower than usual. So one way of doing this is to essentially remove some of the branches with, you know, branchless techniques. Now, this is one of the things I've never really done in the past. I know about it and I know the idea of it, but I don't really know any techniques for doing branchless programming. And that's what we're going to do together, right? So it would be amazing if, instead of having this if statement here to find whenever we have a new line, if we can replace this with something that's not an if statement, right? So yeah, I mean, it's going to be a little bit difficult because this is not a trivial branch per se. We're running quite a lot of things based on this branch itself, and you know, even the inner ones we can have here that we can see here that we have the branchless. Sorry, just the water's gone like into the wrong hole. Let me drink on some more. Yeah, when you breathe too fast and then like both your, I guess your saliva and your and the air you're breathing go into the wrong hole. Anyway, yeah. So if you look even inside this branch statement here, or this if statement, we have more branching inside it, which is like making sure we found the file in the map and so on and so forth, right? So it would be a nice thing to be able to, I guess, remove some of this. So like, I'm not sure if we can remove this one, because at the end of the day, result is the map, right? And we kind of need to find out whether or not the city number, the city name, is already inside the map. Because if we know that there's always something inside the map, then we can always update it instead of doing a branch in here, right? So is there a way to turn this into something that doesn't use the if statement to check if whether or not the map contains something? So say we assume that there's always something in there. So let's see. So results contains. What does contains do? In place hint, insert or assign. What does that do? There are some very interesting functions here. So insert or assign, constant iterator. Maybe there's a function in a dense map that can actually help us. Something like insert or update. That would be interesting, right? That's what we're looking for. Do place element, try place element. Yeah, no, maybe not. I mean, one that grabbed my attention was, let's see if I can find it again. Do try in place or do try in place? No, do try. That was a different one. What is this one? So it tries to in place and it returns an iterator. Yeah, because maybe we can try and in place something. Oh god, what is it? So the key and the arguments. Ooh. Nah, maybe not. Anyway, let's continue with the plan anyway. I was just trying to see if there's a way to do this without the if statement, that's all. So branchless programming, yeah. So it would be nice for us to remove this check, maybe? Can we do this branchlessly? In other words, what is this actually doing? So this if statement is actually finding the line boundaries, right? This is what this is doing. So in other words, can we find the lines without using branches here? That's what I'm going to be Googling in a second. Another thing that we can probably do as well, like we can try and make it, well, we can try and make the find operations a little bit faster as well, because I'm pretty sure that the standard find will probably kind of do an if in there, right? So they'll probably go to each character and do an if statement. Something like an equation is needed to get rid of if statements, but in this context, yeah, something like an equation. We'll see in a second. It's very interesting actually, because you're going to be doing some bit masking and checking bits and stuff. So it's, yeah, we can definitely do some of this branchlessly. So, but I'm just kind of like marking the places where we want to perhaps introduce some of those techniques, right? So that's what we're doing here. And, you know, can we make the find operation faster? And I know already for certain that there is a library indeed that will do this faster than us already, right? So there is a library called, I think, is string find branchless in C++. So I'm not going to be able to find it, but in the Conan.io, I remember seeing one of these really cool rapid libraries for file checking. Stringzilla, that's the one. So Stringzilla does string operations branchlessly, as far as I know, and from what I could see in the implementation. And not only that, it also uses some of the like SIMD, the SIMD instructions to sort of parallelize things a lot better. And yeah, I think it's a good way to start. So maybe we can use this library for now, and then we can take a look at doing some of the stuff that we can't do with Stringzilla manually, right? But this library, as far as I know, it can already replace this line boundary find, which is interesting. And by the way, this is the library I'm talking about, if you guys want to take a look at it. So yeah, SIMD accelerates the string libraries, accelerates exact and fuzzy string matches, added distance computations, lazy, okay. And it seems to be fairly performant when I was looking at it. So like, if you look into the C++ find, it's 1 gigabyte, 1.6 gigabytes per second that you can go through. With Stringzilla, it's 7, so it's really good, right? Or in fact, if we're looking at x86, which is the one we're looking at, is even faster. It's 10 gigabytes per second versus 2.9. So yeah, should we try and do this? I think we should probably try this. Let's hope that it kind of just builds fine for us. Again, I'm going to be using the Conan file. I'm going to go down here, add that in there. By the way, I'm like using libraries to do all this stuff because I want to solve this thing fast. But if you want to get into the topic of branchless programming, which we will in a bit as well, we do some stuff manually. It's a huge sort of like topic of computation, and there are many different like techniques you can apply for certain like common operations. So for example, you can do equals. You can check if something is equal to something else in branchless. You can check if something is less than the other in branchless. It's really good. And it's what kind of compilers do automatically for you. So when you create a function to find like minimum or maximum functions in C++, and considering you make it, you know, kind of simple enough and not very difficult for the compiler to understand, it will automatically kind of apply some of those optimizations to your code, and the generated assembly is most likely going to be branchless. So anyway, so let's do a Conan install in a Conan debug. Conan is working like a charm in the last few days. I'm loving it. I'm absolutely loving it. Okay. Now, Stringzilla, I don't actually know how to use it because I've not tried it before. I just saw it today and I was like, hey, let's give this a try on stream. So let's see some of the actual usage, right? So maturity substring is there. Edit distances. What do the emojis mean? So for the C++ 11, okay. this is the usage in Python though. I want the C++ usage. Where is it? Yeah, like what? I just still don't understand. Sorry, like what is this? Like, is it implemented? Is it not? Just put a cross here, dude. If it's not, it's fine. Just makes it more understandable. Quick start and C and C++. Right, here we go. Basic usage for C++. It says below. Oh yeah, it probably would help if I read a legend, wouldn't it, Robin? Parts are in beta. Alright, they're in beta. Parts are under active development and likely to break in subsequent releases. Are implemented, are not implemented. Cool. Yeah, it would help a lot if I read a legend and didn't just start complaining straight away. There was a cool partition function I saw, which might be what we want. Like this. Beyond the C++ standard library, learning from Python. Okay, let's not learn from Python, but what is it? Python's arguably the most popular programming language for data science. In part, that's due to the simplicity of its standard interfaces. Stringzilla brings some of that functionality to C++. Partitioning. Ah, see, this is kind of what we want then, right? So we want this haystack thing, and we want to partition it on that exactly. So just a character. And let me try that. I mean, this looks promising, right? Because this is essentially the line that we want. Oh, let's hope it doesn't use regex, because that would really mess things up for us. So Stringzilla. Oh, yeah, not available obviously because we haven't added the package here. Is that gonna work? Oh yeah, Stringzilla. So now if we just do Stringzilla. I like the name as well. Like, I love when libraries actually have a cool name. So, and that's one of the things I'm kind of terrible at, just naming my things properly. And in a way that people actually enjoy the names, but yeah. Stringzilla, haystack. Okay, now what do we actually call this? Like, how do we call the headers? Let's see. So we know there's a partition function that obviously we want to use, but how do we include the header? So include anywhere. Stringzilla. It should have just been Stringzilla. I don't know why it's not coming up here. So this is threadpool app, right? Stringzilla.h seems to be the one. Oh. Does it actually get found? Clean build. Yeah, seems to actually get found. Yeah, let's take a look at the line itself, right? So once we found the line, we're going to replace some of this code here with the Stringzilla. So string. What is that? So sz partition, similar to partition, given the predicate, it splits the sequence into two parts. Wait, how do you use that partition again? Like, what is haystack? How do we use this? Is it worth creating one of these? I do one. Do wonder. Initialize your haystack and needle. I like this idea, but where is this going though? Ah, they've got different functions as well, performing string level operations, as defined. And your text length. I don't understand this idea, so let's see. So basic usage with C++99 and newer. No. There you go. So there is a stable C++ interface available in this namespace. It comes with two stl-like classes, string view. The first is a non-owning. Okay, I want this one. So how do I get this one? Yeah. So this one has small string optimization, which is going to be helpful in some of the cases. For those who don't know, small string optimizations in C++ are very useful. So basically it's the idea that if you have a very small string, something like, I think it's like up to 16 characters, then that string data is actually stored in the stack and not in the heap, right? Which makes things a lot faster. So yeah. Why do I need a needle? So a string haystack, some string. Ah, okay, so you're finding a needle in a haystack. It's a good example, actually. I'm just an idiot. So, right. We do need to create the string itself, right? So yeah, why don't we have the stringzilla? Like C++ thing, the C++ namespace. Which version are we on now? So this is version 3. Version 3 and this is version 2. Okay, so I guess there is a difference here, isn't there? On the Conan one. What do we have in version 2? Let's see. Version 2. Actually, yeah, the Conan recipes are quite behind, actually. Yeah, look. In this version, they didn't have the C++ one at all. Yeah, they've added a C++ interface later on. So we're playing with this version, it's fine. It's fine. Ay, 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 ay. So this is what we want, right? So we need se string view, is that right? String view t. Now what do we actually have here? Is this the start t is a pointer to a character? Okay, good, good. So in this case, it's kind of very easy, right? So we can remove this line. In fact, now is this going to work here? So no, that's the start. And what we want to do is that minus the starting, the string start, right? And then this should have been a begin. Oh. Constant iterator begin, yeah. And this is our line. Now can we do a line dot OSE string partition here? That would be interesting, wouldn't it? Hello there, Redemption. Hello Al, how's it going? Let's good to see you, man. Good to see you. I haven't had a chance to look at your latest PI yet, dude, but I saw it there. I'll try and do it tonight, but if not, I'll do it tomorrow. Thing is, I'm actually going to London tomorrow, and I'll be away for maybe 4 days. But rest assured, your PIs will be reviewed, man. I'll still have my laptop and stuff. I'll be on the hotel, just like boom. I'm actually going to the Rust Nation conference. So it's going to be a workshop day on Tuesday and then 2 days of Rust conference after that. So yeah. But yeah, I mean, it still finishes at 5, right? So I can still have some time to do some video stuff later on. Well, not videos, but you know, coding stuff later on. Partition. So what does that return to us? A sequence and a sequence predicate. So partition, is that going to be in here? Partition. Coming soon, partition. Okay. But we have the what's that as the sequence thing? So the order, the count. So this takes, wait, what? Can I just find it? Let's see if I can just find it, right? So if I do se find one character, and we have a few different ones here. So there's one character schwa version, 8 characters at a time. Let's try the different ones, right, and see what happens. So what does this return? This returns a start T. So the haystack is the star, the size T, and that is just a, character star haystack length, and then we also have the needle, what we want to start. Okay, so in this case we want to do line dot start, I guess. We want to do line dot length in this case. And the needle that we want is actually this, right? Correct? No? Find one character. Why don't they just take a character instead of like a pointer to a character if it's just one character? I don't understand this. That's schwa anyway. Anyway, so that is... value of type character not beyond. Oh, God's sake. Okay. And we want to find the delimiter. Okay, so that should return. I think that returns a position, right? So a string star. Wait, so what does this return? This returns a string star, which is a pointer to a character. By the way, should the delimiter not be outside the for loop? Yeah, it can be outside the for loop. Right. You are quite right, though. Something like that. So this is, we're dealing simply with the C interface here. That's why things look a little bit backwards, is because this is a C interface, which is what it is, right? So and there's the limiter pointer. Yeah, now you know this will give us a pointer to the delimiter inside the line. So what we need to do is actually calculate the position, right? So in this case, it will be something. Yeah, we're going to skip the bounce check in this case. So it gives us the delimiter pointer to the pointer where it is on the string. And what we can do is we can substring that now, right? So if we do z dot string substring, is that a thing? Find substring schwa. What does that one do? There is an if statement there. Well, I think it can work with the string view in this case. Because now we know for certain that we have the limiter pointer, which means we can have a line.start here, right? What's this not? May not have a temp. Oh yeah, it's a string view. What the hell am I doing? String view line.start. And then the size of it, which is the delimiter pointer. Actually, this is the town, this city name, right? Or station name. There you go. Make it a little bit better. So we get the size of the string straight away. So the station name is going to be this, and then we also have the limiter pointer, right? So we're going to start +1 and then the line dot length minus delim position. I think that should work. So this is going to be the temperature itself. Line start plus find one character. Line start plus find one character. Oh yes. No, you're wrong. It's going to be this actually. It's wherever it finds the first character minus line.start. Because this will give me a position. Yeah, it's just a fucking pointer difference now. Well, thank you for pointing it out because it was wrong though. It was the other way around before. So this is where the pointer to the comma, sorry, the pointer to the semicolon in the string, and this is where the line, or the first byte in the string, right? So the position is going to be that difference. And in here, what do we have? So this has to be yeah, no, I guess we're gonna have to like scash that thing anyway. So this is the lim pointer is gonna be CZ. Find one car. Copyright. Miss me with that. That kind of works if we assume that things just if we assume that all the lines have a semicolon and a character after the line as well, this should work, right? So now we have the temperature, string, and that. So we can run this from characters, And again, I'm using from characters now to convert the temperature string to a float, but I'm pretty sure it's probably not the most efficient way of doing it. We can hand roll our own conversion. And the city name, we already have that, so station name. So what's station name in this case? String view. Oh, no way. We're gonna have to create a string here because ankerl doesn't work with string views. Comparing string views to strings in a key. A bit of annoying. Is it city name or station name? There you go. Now, I mean, we've changed everything to the string view library. Sorry, the stringzilla library, but will it actually make a difference? Let's see. And I'm hoping I'm not like leaking any data or anything like that. Oh, why is this messing up things? Why can't I see things? Ah, okay, no, this is running the wrong one anyway. That makes sense. Because I compiled it for release and it's still running the old debug file which we had from like last week. That's why. But if I switch it, it should be... Oh, no, it should not be Gucci. What is going on here though? So ankerl den's not found. File not found. Is it because we forgot to do a Conan install on the debug? What? Okay, yeah, we're fine. Okay. Yeah, it was just a Conan install. Gone wrong. Right, station name. The limiter position. Station name. I mean, seems to be going good, right? I don't know. Puran, Tokyo. Yeah. Now, if I let it run until the end, what do we actually have? I get the feeling that it probably didn't help things too much, but we can see. So Tokyo second. So for example, Tokyo, we seem to have something good, right, I guess. Tokyo's definitely going to have more than Jakarta. Okay, good. I mean, anyway, so we had like 0.8 seconds, I think, in total. And, you know, it's not done much here. Not done much at all. In fact, it increased the time. Increased the time by quite a lot. It was 0.7 to 0.8, now it's like 0.87 to 1 second. So it's not ideal. Maybe if we run this on more cores, who knows, let's try 6 cores here and see what happens. Which means we have more chunks. Now let's try and decrease this, shall we? So also going to build it for release because that's what we're trying on the terminal. As far as I know, string view is not really performing Yeah, this is not a string view. This is a different library. String view is more performant than this library currently. So, okay, so going back to 6 threads kind of hurts it a little bit. What if we do 4 threads instead? So 4 threads on my machine seem to be like the sweet spot. Yeah, interesting. So having a string view here and having the previous delimiters that we have is better than this, as far as I can tell. So we had line.find first of, I think. Is this 1 mil or the whole 1 billion? This is 10 million. Neither one or the other. It's 10 million lines. So this find first off, what does it return me? It returns me a size type. So substring kind of works, and we have from 0 to the limited position. And at the end here we have that's essentially what we had, right? Maybe Clang is just really good and it's like optimizing these operations for us anyway. Who knows? See? 93, 97. It's the same, I guess. It looks the same. We didn't really gain any massive performance in her. So I'm kind of inclined to just leave it with the string view at the moment. Like, yes, it would be nice for us to find this in a branchless way, but is it worth it? Can we? Maybe we can do that. Yeah, let's read into it. Can we find a string? Can we do a string find in branchless? Let's see if we can find a string character in branchless somehow. We have a file that I want to read. No, if one of the lines contains this, we'll try that. I am wondering though, what does it mean for a string to have a semicolon in it, right? So a string could be something like this, right? So if we want to find a semicolon in a way that we don't use branchless, what we can do is we can convert these to bytes, I guess, right? And we can take away from each byte wait a second, what is the ASCII code for this? Because if it's less than all of the other letters or the other characters, then it's kind of easy. We can just take away one string from the one full of like semicolons. And then wherever we get 0, that's, you know, we know that that's when we have a semicolon in there, right? where's the ASCII table? Just give me the ASCII table. Thank you very much. So we have... Yeah, see, we have that. But the problem is that we also have digits in it. So if we take away all the bytes from the string by 3b here, we're still going to end up with some negative numbers, which isn't ideal. 59 in decimal or 3bx in decimal. Oh yeah. Thank you, Robin. I mean, and all the bytes really in C++, all of this is less than 127, which means that we don't really need the last byte. Should we do a test? Let's do a test program, right? Let's do a little test. Yeah, we can actually do it at the very top here. Doesn't matter. This is some test stuff. So say we had like a little string, so std string. Or in fact, yeah, let's do a string. Or can we do a constant, a string view? String view. And we want to find the position of this, right? So what do we do? We could assume that the maximum length of the string is something like 100, right? And by doing that, we can compare it to like, or we can take away each, oh no, maybe we can't. Maybe we can pass the string to like a bunch of uint 80s. Sorry, uint 64Ts. And then do a comparison. Wait. Yeah, so ooh, this is getting harder and harder. So 64, right? So instead we get the 8 bytes that we have here. So 8 bytes at a time. 1, 2, 3, 4, 5, 6, 7, 8. Transform that into a uint 64T, and then we compare it to whatever mask we have, right? So comparator. Let's call it comparator for now, and that is essentially just the 0. X binary, sorry, the binary or the hexadecimal for semicolons in all the positions, right? All the positions. I'm still thinking about this. I'm not sure if it's going to work, but let's try. Something like, what do we need? We need 8, a 3b. So something like that. Right, this is a string that has, well, it's not a string. This is a uint 64T that we get from doing the hex code for this over and over again. That's all we have here. So where are we going with this? So if we now kind of do uint 64T and we get a first 8 here for the string. And what can we do here in this case? What is this song? Oh, it's Minecraft, Terraria, of course. Yeah, so we have test and this gaze, which is going to be something like 0 for now. And then we can mem copy. Mem copy, we've got destination and... Okay, so the destination is going to be the test. And we're going to copy the test.c string. That's test.data actually. And we're going to copy the size of so we're going to do something like this. So in essence, now we can do something like test minus comparator. But the thing is, I don't want to underflow this. Underflow or wrap around, whatever it is. Because some of these values here, like minus, 0, 1, the dot, they are before the comma. So what do we do here? So what I want to do is essentially do a bitwise minus. So a bytewise minus. In C++. I don't want it to carry over. I don't want the carry, basically. That's what I want to do. So what do we do? Because I am now interested. If we can do this for any value, is that even an operation that's valid in binary? Is that even an operation that's valid? Huh. It must be like something similar to what I'm trying to do. I'm not too sure now if this is going to work, but what's going on here? Okay. What the hell? Size of... What the hell? Jesus, what's going on with my typing today? Ah, I've got caps lock on with the Vim. Of course, that's wreaking havoc here. Right. Yeah, so I'm basically trying to do the byte for H minus this here, 3B, and the byte for E minus 3B, and so on and so forth, but I don't want the results to carry on. So how do I do that? And see, is that even a valid operation? So subtract 1 without arithmetic operators. Cool. This is just bit shift. what is this one doing? So check if a number is positive, negative, or 0 using bit operators. Given a number n, check if it's positive, negative, or 0 without using conditional statements. So branchless. The sign bit shift converts every negative number into -1. And every other into 0. Yeah, okay. So when we do a bit shift -n to that, if it's positive number, it will return -1, as we are doing -1 to 31, and vice versa when we do for negative. I mean, it's a cool way of checking if it's a positive or negative with branchless. But you're also assuming the size of int, so you need to use at least an int32 there for it to make sense. Some machines have int as 16 bits. There you go, byte-wise operator, that's what I'm looking for. Yeah, I'm just gonna stare at the ASCII table for a second and see if there's like an easier pattern that I can make here. There must be a way to find strings or find characters in strings without if statements. I think we're on the right lines though. I just don't know the right technique to do this. Yeah, this is going to be a difficult one. It's going to be a difficult one indeed. Has no one really made a blog post or anything like finding strings or characters with branchless? What is this? My Facebook. Oh God. Yeah, I don't know. I don't know what we can do now. I am kind of stuck. I can't think of a branchless way of doing string find. Maybe we can take a look at the greats. Right? We can take a look at what the people at 1 billion challenge in C++ did. Sorry, 1 billion challenge in Java did. Okay, where do we go to the actual GitHub thing? Dude. There you go. So I know that some of them did use branchless. But native binary uses unsafe. The solution starts the child worker process. We took a look at this the other day. I think this is where I got the idea of branchless from. runs in 0.31 seconds in an Intel. Could you not do something with module, for example? Take the character code plus the character code from the delimiter, and then do modulo the character code for the delimiter. If it's 0, it's a match. Yeah, that's what miners will do, by the way. Oh, this is... It just sounded exactly like Kingdom Hearts, so I thought, let's remove that. So that's the idea for the minus here. If I could do like a byte-wise minus that doesn't carry on and borrow, then if you do this, whatever this number is, minus this one, you will get zeros only where you have the semicolon, and then numbers, well, that are not zero elsewhere, right? And then with that, we can do like a bit mask to find it, essentially. So we can use the result of that and then do a bit mask for, say you have different variables like found position 1, found position 2. Only one of those would be true, depending on what bit mask you do. So yeah. Like, use a little bit more memory, but it's worth it. The module operator will kind of achieve the same thing if you think about it, but the thing with the module operator is that I think it's more costly than minus, right? I'm not too sure now. You caught me on that one. Minus versus mod assembly. I want to see what the usual assembly is like. How many cycles do each one of them take, usually? Oh no, 1 hour and 60 minutes of my life went to waste. I missed the start of the stream. Hello, Arkanaf. Welcome, dude. I just want to read a... I want to see which one's more efficient, because I'm not too sure now. Module cycle. So in this case, it's got MOV, which is not what we want. We want a module. What even is the instruction for module? Maybe you're right. It seems like module is just kind of a simple AND. So it will be faster than minus. Maybe I can't get a straight answer, sorry. We'll try both. We'll try both. I mean, they both will achieve the same thing in this case, though, leaving you with a 0, only where you have the semicolon. So yeah. But dude, what the hell? Let's see what these guys are doing here. The segments are split into 3 parts, and cursor for each of those parts, processing segments simultaneously. The results are accumulated into a link result object, and a tree map is used sequentially to accumulate the results. Yeah, this is kind of what we're doing now. So Q1 made for branchless number parsing code. That would be cool if we had branchless number parsing code. So to parse the minus 10.1, for example, from a string to a float. Alfonso 2 Peterson for suggesting memory mapping with unsafe. We got unsafe already. Stealing at 2 megabyte segments instead of equal split between workers. Showing that avoiding the branching misprediction between less than 8 and 8 to 10 cases is a big win, even if more work is performed. I don't understand that. So this is spawning a worker. Is there a, like, where do we actually look at the function that's kind of getting the files? Sorry, the lines. So we've got file channel, map, read only, file size. Parse loop. Good luck with this challenge. I'll go do some rustling. Rusting? Alright. Well, good luck on the rust, dude. And thank you for joining, man. Don't forget to drop a like before you go, and I'll see you next time. Thank you, dude. Have a good weekend. Well, a good end of Sunday. So parse loop. So we got a counter file start. Okay, this is the big one. This is the big one. Let's see what they do. Cool. This is calculating the segment stuff the same way as we kind of did. Segment start. So if current file. Okay, so they get the next new line and shit as well. Okay, so they get the new line on the right instead of on the left. I'm glad that at least that is that seems to be the common implementation, which is what we did in the last stream. But we get the line on the left. So scanner, we don't care about that stuff for now. I don't know what this does. While because true. Well, scanner has next, scanner 1 and scanner 3. So he splits the whole. What is a scanner? This seems to be what scans the file, is that correct? Okay, I have no idea actually. Line start, line end. This just feels like a string view implementation, basically. It just feels like they implemented their string view here. Where is the parser loop again? Parser loop, here. So long word 1, word 2, and word 3. What does get long in this case? Okay, get long seems to translate the text into a long, right? Which is what I was kind of trying to do with some of the text. So they get word 1, 2, and 3. Find the limiter. Now this is the interesting one. How do they find the delimiter? Oh, there you go. It's some sort of branchless shit. Oh. What is this? What are they doing here? That is interesting. So they can do something like that. One sec, replying to a video. Replying to a comment. You got the complement operator there. Anyway, let's go back to this. The amazing world of bit manipulation. I remember I was there 30 years ago. Yeah, this is Java as well. Question is, what does the hat do? Wait, do we have hat in C++? I don't actually know. Hat operator, is it? I thought it was like a complement or... Yeah, what does the hat operator do in Java? Because hat is not a thing in C++, is it? Modifies the type specifier. That means that the declared object should be automatically deleted. Oh no, this is Microsoft managed C++ stuff. We don't want that. So hat operator Java. What does the hat operator do? Exclusive OR, right? Yeah, that makes sense. So exclusive OR. Do we have XOR in C++? Oh, it should be XOR, right? Yeah. So why are they doing that? So they get the exclusive OR, which just gets the different bits, which means that you end up yeah, just make sure that you only end up with ones whenever you have either one in each one but not both. If both are the same, you get zeros everywhere, right? So this is what we want to do, really. They've got what we want to do. I don't know why I didn't think of XOR, exclusive OR, because then you end up with ones wherever one of these doesn't match them. And then it did, wait, yeah, let's see, long import. We have the word over that, so they're trying to get the yeah, this is true branchless stuff. Yeah, so you basically end up with ones whenever the character is not a, I guess a what do you call it? A semicolon. And that is saved to the import. And then what does that do? I don't understand this logic here. This is going to be interesting. Somehow this finds the position of the delimiter in a word. And you can see it, we separate it into 3 words. So what they're doing is they are kind of 1, 2, 3, 1B, 1, 2, 1, 3. They're kind of splitting the lines into 8 times 3 characters, so 24 characters. Is that what they're doing? Yeah, they're splitting the line into 24 characters. And they expect that the delimiter is going to be in one of those 24 characters, the first ones anyway. Oh no, they're doing way more than that. They got the first 3 characters here, and then the second 3 characters there. Sorry, the second 8 characters in here. So really, they are doing this. So they expect the delimiter to show up in the first 48 characters. Where are we? Oh my god, I've lost it. I've lost it. Where are we? Here. So this is the delimiter mask. They actually get a mask here. Huh. Beat G2 is the ultimate skill to learn. Yeah, it seems like it is, yeah. I kind of get an idea though of what they're trying to do here. So as you said, as we know, XOR is going to give us that. Well, there's an L at the end, so I don't understand here what. Oh, it just represents a long, right? I guess doesn't matter. Yeah, so that XOR is going to give us the position where the comma is in the string by having zeros everywhere in a particular byte. So that only happens when you have a comma, a semicolon, sorry. But I don't know what this bit is doing. This bit is clearly creating a mask of some sort, because then we have this minus that, and then the complement of this Can ChatGPT describe this for us? That's the question. Or even better, can Bing describe it for us? Describe how the find the limiter Java function in this page works to find the character in a byte long string. We gave it some context. Let's see if we can access it then. The method likely involves bitwise operate. What do you mean likely involves? It's here. It does involve bitwise operations. Okay, no, it's actually trying to explain the rest of it. Let's let it cook. Let it cook, and then we can read the rest of it. So input processing. Stop moving. So the function takes an a byte long string as input. This could be represented as a long data. Yeah, it could. Bitwise operations. The function uses bitwise operations to manipulate the string. For example, the XOR operator is a bitwise XOR, and the AND operator, yeah, we know that. The limiter detection. So the specific operations input minus that and input and that are common techniques to detect the presence of a specific byte in a value long. This value is used to subtract 1 from each byte. Okay. And this value is used to detect if any byte was originally 0, 0, which would indicate the end of a C-style string. I don't think this explains it very well, guys. I'm not sure about you, but I still don't understand this. In the context of finding the semicolon character, the function would need to compare each byte in the input to the ASCII value of this, which is 3b. If the input string is word this, it means that the original string is XORed with a long consisting of this characters repeated. Yes, we know that. The result of the operation would reveal the position of the character within the a byte string. Yeah, no, I understand that, but how does this... what does this do? Like this bit here. Yeah, no, that was not very helpful. That was not very helpful. But we can begin with this, right? We can kind of try and find where things are in C++. It returns the position of the character in the string array. Does it? It returns a mask, I think. That's what that's what it looks like it does. The limiter mask here. Can you go back where that specific function is called? Yeah, so this is it. So they get they split the line into two sets. Sorry, 6 different a byte strings in a long, and each of those a bytes is given into this, and then once each word is run through the delimiter function, I probably think that this is, wait, what is word 1b get long at? Yeah, I probably think that this find result probably gives us the answer to it, right? Let's see what find result does. Initial word delimiter. Yeah, this does a lot of shit. Do we want to be bothered by reading this now? Dude, this is crazy. No wonder why these guys won this stuff, because they probably did a lot of hard work to get all of this string find stuff into branchless. I mean, up until now, up until finding the delimiter, everything's kind of small and, you know, possibly understandable if you know what this is, but then you go to find result and yeah, and then you go to the find result function where this stuff is used, and then that's where it falls off. That is where it falls off. Like, what the hell? I need to be on something to be able to read this, because it's, yeah, not gonna happen today. Not gonna happen right now. Yeah. They've got one for the next new line as well. Like, they find the next new line with branchless, from the looks of it. You can do that when you're on the toilet alone with a phone in your hand. Probably, yeah. See, they've got like branchless functions for every single thing that we have currently. So like we struggle to find a new line, and they've got a branchless function that finds the new lines. I'm gonna break out of the loop. This is crazy, this is crazy. Yeah, I don't think we're gonna go with this for now. We're gonna definitely put a rest on it and digest some of that, because it's crazy. I mean, clearly I'm on the right tracks. I was kind of on the right tracks by doing something like this, but yeah, we're still far. We're still far. So are we going to be able to succeed on this? I don't know. For now, what do we have? We have 10 million lines being done in 1.13 seconds. Not very happy with it, but yeah, I don't know. I don't know how the time went up as well, because we definitely had 0.7 seconds earlier, and I don't know what I changed here to make this happen. Yeah, boys. I'll follow the sleep now, guys. I'm actually going to call the stream here. It's going to be an early one. I have to wake up really early in the morning tomorrow to go to London. And that kind of means that I won't be able to do any streams for the next 3 days or so, but I'll try and come up with something that's actually interesting, because now we're kind of stuck here, and it's not very interesting when we're actually just stuck in a problem and we can't find a solution. In the meantime, since I will be in London and I won't be at home, meaning that I'll have nothing to do, I am probably going to work on the branchless stuff and see if I can get something out in C++. So thanks for the stream. Thank you for watching. What do you do in London? I'm going to be there for work and a conference as well. I'll be going to a Rust conference. Hello Slim. Dude, you always get in just as I'm about to shut down the stream. But don't forget to drop a like though. But yeah, since I'll be in London for the next few days, until Thursday actually, so I'm not sure if I'll be able to kind of do a stream on Thursday, but definitely on Friday though. Keep an eye out for that. Then yeah, I'll come up with some good stream ideas. I might go back to a bit of Rust. I've not done some Rust in a while now. And maybe Urchin as well. Golang. And if I can find a solution to this, if I can make this branchless, I'm happy to stream it and then teach you through things. But like at the moment, I'm not taking anything in. So wait, let me Discord you my solution. Oh yeah, let's see. I'm expecting great things. Yeah, let's wait for that. Let's wait for Slim solution and I'll actually run it here. So give it to me, Slim. If you give it to me in the next 2 minutes, dude, I'll actually try and compile it and run it. The 1 billion row challenge. Right, bro. C++, 2 weeks ago. It's actually fairly simple, isn't it? What do you have here? So we've got the min, maximum, average, total temperature, and temperature count. You've got something quite similar to what I did actually. I don't start the average though, because the average is only going to be calculated at the end. Process chunk. So what do you have here? So we've got an iString stream, I guess, to create the lines, right? So what are you doing here? So you get the line, yeah, you're using the C++ standard to get the line content and to read the file. That's cool. Assuming the line has a temperature, yeah. So you skip the bounds checks in this case, which is what I do as well. You do a line find, line substring. Cool. Yeah, I mean this is a fairly good one. You do have a try catch here though, which isn't ideal for performance. Probably gonna drag it down a little bit. File path 1 bil. So you did the buffer size of 64 megabytes. I guess you googled it as well, right? Because I did a Google on this, and apparently the 64 megabyte buffer size is the best one you can use for file reading and mappings in general, which is pretty cool. Should we try and run this? Yeah, before we leave, let's try and run this real quick. I'm not gonna lie, Slim, I think it's gonna be quite slow, right? Because I can already tell that, you know, just from reading the file and using strings and doing string substrings and finds, those tend to be quite slow already, if you don't use any like initial optimizations. Somewhere in my guts, I still feel like we should be able to go with one side track for detecting overshoots. I guess, yeah. Took 13 seconds to process. Wait, 13 seconds to process 1 billion? What? That is interesting. It took 13 seconds so far. I can aim for 5 seconds. That's crazy. Like, mine would take, I don't know, mine is 10 million lines and it's not even a second, but 100 seconds? That's crazy. Wait, does it actually? Let's try it. And this is on my machine, by the way. I don't know. Your machine might be faster. So, git clone. So how are you compiling this stuff, dude? Oh, you do have a CMake here. And you have a VC package. What are you using? What are you using? FMT. So the only thing you really have is VC package. Okay, I do have VC package. That's cool. Do I actually have VC package installed in this? Just change the file path to your 10K. Yeah, I'll change that to the 10K. But you have FMT. Are you actually using FMT, or can I just remove it real quick? Oh, you are actually using FMT. That's fine. Just remove it. Yeah, I can just remove it, but I can also try to get this quite right here. Okay, so bootstrap. Okay. It is VC package install, right? If I'm not mistaken. Dude, I actually forgot VC package's freaking install command. Can you believe that? Ah, yeah, of course. We need to add that to... How do you do the environment variable here? There you go. Now I know somewhere in this there is a toolchain file, which is in scripts, right? CMake. No, it's not. It's in build trees, downloads, ports, tools, triplets. Toolchains, there you go. No. Build systems, that's the one. Right, VC package CMake. So we are in script, build systems. CMake, let's go with Clang 17, shall we? There you go. This is probably going to download FNT properly now. Yeah, switching between Clang and, sorry, VC package and coding all the time is kind of annoying. It says configuring the project. Is it actually configuring? Why is my freaking VC package stuff not installing here? Let's try again. I tried to use a nice hash map. We were talking about a nice hash map earlier on, actually, dude. Should go back in the stream at the start. Right, for some reason this is... CMake configure. C++. Version 3. Let's try the command line. Don't know, maybe VS Code has just been annoying. So CMake dot. The directory 1 billion row. Okay, there you go. So we don't have... Yeah, I'm just gonna delete it, dude. Then I'll compile it later, because, geez. For now, I don't wanna set everything. You don't need it, yeah. Flash maps, brother. Ah, you also set it here. That's probably why, by the way. That's probably why it wasn't working, because it was resetting with your value. Anyway. Right. The printing should be fairly easy anyway, so. Okay. I'm kind of skeptical that it's not actually running, so let's put some here. Okay. Okay. Yeah, so unless this shows this, we know that it's not working, right? So let's put this file. For now, I'm going to hard code it to my machine. Right. There you go, so that's finished running. So it did actually run this time, but it takes, on my machine anyway, 11 seconds on 10 million lines. So yeah, dude, you might see our little reason why I love FMT. Yeah. So it's good, Slim. It's only 11 seconds. It could be a lot more though, because this is 10 million lines. But you might benefit for some of the stuff that we've been doing in the streams though. I'm on a quite old machine actually, so my spikes are I think I've got like a 10th or 11th generation i7. It's like 3 years old now. And this is also running WSL, as I said, so it's quite slow already, just because it's WSL, it's not like native. If I switch this to native, it'll probably take it down to like 7 seconds. But I like working on WSL, so that's what I'm saying. Some of the stuff that you might benefit from are like, from what I can see straight away, so you can take it down from 11 seconds here to 0.9 if we do file mappings instead of just doing the stud reading, like input and output. Sorry, the stud file reading stuff. You can also do like more efficient chunking from what I can see here on your code. And you can use a very nice hash map called dense map, and for that you're gonna have to go to the start of the stream where we talked about it. But yeah, but anyway, this is good though. 11 seconds is really good for a first try. And you got to understand that some of the people who are on the winning board for the 1 billion challenge, they've been working on this for like literally 2 months non-stop with like 4 other people, and they really wrote some hardcore branchless code just to make things work very specifically for this problem. So yeah, anyway, I'm gonna shut it down now, guys, and thank you very much for watching. And yeah, keep it going, Slim. I want to see you make those improvements on the code, so just rewatch some of the streams and then you can kind of copy what we're doing. And yeah, I guess I'll see you guys next time. Have a good week, and bye bye. Thank you all for joining.